Alright, so this is the final code that I kind of have here. You can see that I set the reverse direction, and then I do stop and reset encoder. I actually do a target position tolerance, and those are in encoder tick counts. And then you set the target position, then you do run to position. A quick little thing that I do want to mention is that if you actually do this in an actual FTC robot, it'll actually throw you an error if you do run to position before target position, because run to position needs a target position to be able to work. So moving down here, you can see I do the wobble actuator again. I set the power, and then I don't have to set the power back to 0 until I then turn it off, or I stop and drop off the wobble go here. So you can see right here, all that I do is I set the target position to its previous target position plus a new inches of 75. So basically I'm incrementing the target position by 75 for all of these, and then it moves forward 75. And then it waits until they're not busy anymore. That's using the target position tolerance and the target position as well as the current position, and it's comparing all those values. And then it basically says while the front left is busy or the front right is busy, then it will keep like basically staying in this part of the code. But as soon as they're both not busy anymore and it's moved to its final position, it will then move on to the next bit of code. And then after that, I basically do, you can see plus, minus, minus, plus. It strays 17.5 inches to the right here, and then it goes forward again 15 inches, and then it drops it off here. I just kind of do a regular sleep function, and then at the end, I just go backward negative 15 inches. Now, you can see that I have this weird block here that you probably don't have, and that's a function. I'm doing a return function here, so basically, I can have a do something function, and then I could do something like telemetry output key number and then return pi. So then if I go into the functions here, you can see that there's now a do something function here that I can plug into something. So if I like plug it into another telemetry that has a number, then you can see that it'll actually run this function and it will output this key, but then it will also return pi back into here. And this is kind of the function that I have here in terms of you input inches, as you can see here, and then what it does is it sets the ticks variable to inches divided by the circumference multiplied by the encoder tick count, and then it basically just returns these ticks. Because I didn't want to have to do this for every single block there, it just kind of cleans up the code a bit, which we'll get a little bit more into later, because you can see that this is also kind of a lot to do, and it's sort of a repeating pattern of what you have to do as well, if you've noticed that. So hopefully that was kind of understandable. I'd recommend kind of experimenting around with it again and trying to kind of learn kind of the intricacies of this a bit more, as we'll be moving on to some other complicated math and problems. And now you can kind of see why this is labeled as difficulty hard. So I recommend, before moving on to the next one, fully kind of understanding and going through kind of the steps and thought processes here and fully understanding it before you move on to the next one.